In this video, we are going to get a handle on the octet rule and the exceptions of the octet rule. We're going to go ahead and jump right in because this is kind of a lengthy video. I try to keep them as short as possible. So first of all, what is an octet? Well, in my mind, I just remember that it's a rule of 8. So if we have a CH2F2 molecule, I know we need 20 valence electrons. If you're confused on how I know that, you should go check out your video library and find your Lewis structure video, and it should be able to help you figure out your valence electrons if you're struggling with that. So we're going to go ahead and just draw our element out. We have our hydrogens and our fluorines. We've connected them with our electrons, and because 2 electrons can be represented by a dash, so that's where we're at. We have 2, 4, 6, 8. That means carbon has an octet. It is a happy carbon. Then we have in the fluorine 2, 4, 6, 8 on both sides. Fluorine, totally happy. Hydrogen is an exception to the rule. We're going to get into that right now. So octet rule exception number 1, hydrogen. That's where we were going. So we have a hydrogen molecule. That hydrogen molecule only has 1 electron. It only needs 2 to complete an octet. So hydrogen is going to bond to itself or other atoms in order to find those 2 electrons. So both of these hydrogen atoms both have 1 valence electron, but what happens is they come over and they bond with each other, and that fills up that outer shell and it makes hydrogen happy. So hydrogen is the first exception to the octet rule. Now we have a second exception, our octet rule exception number 2, and really what we want to talk about is helium. We're kind of in the same boat that we are with hydrogen. It has 2 in its outer shell. It's going to want, if for some reason we go and we bond it with something else, it's going to have to go into the next energy shell. So I just want to throw that out there too. All right, octet rule exception number 3, we're going to want to talk about lithium a little bit. So lithium has 3 valence electrons, 2 in the inner shell and 1 in the outer shell. And we're looking at 1 valence electron. Now that valence electron just goes away. And now it's almost like helium because it has 2 valence electrons in its first energy shell. But what happens is when something loses an electron, it has a charge, and that's where your lithium plus charge comes in, okay? And that's a single positive 1 because it lost that outer shell. And so just another idea for you to keep in the back of your mind when you're thinking about all the exceptions that go with the octet rule. So our fourth octet rule exception is going to be beryllium. Now beryllium, we're in the same boat, okay? What happens is in that outer shell, we're going to lose those 2 electrons. So what that means is we're going to end up with a positive 2 charge, okay? And as we get a little further into this particular video, I'm going to show you a periodic table that gives you some charges and gives you some ideas, and that should also be available to you in your D2L. If you cannot find it, reach out to your instructor, and your instructor can help you get to where you need to be. So we're looking at beryllium with a 2 positive charge, and here is the periodic table of elements that I just told you about. I have lithium, beryllium, and if you look at all of these, they all have a positive 2 charge. And so that gives you an idea. They're in group 2, right? And so it kind of gives you an idea of where we're getting these charges from. So now we have octet rule exception number 5. And this is a big one, expanded octets. In the periodic table that we just looked at right here, our periods, our groups are here, okay? Our periods go across, okay? So anything in the 3rd period and below can have an octet. So let's just kind of do one. Let's just see what we're talking about. So we have a PCl5, okay? A PCl5. We're going to go ahead. We know that we need 40 valence electrons. Again, if you don't know where those valence electrons come from, check out your Lewis structure video in your video library. I'm going to go ahead and put everything up here for us so we can see we have all of our electrons, all of our chlorines, they have octets, they are happy. However, if you look at that phosphorus, it has 2, 4, 6, 8, 10, okay? It has got 10 valence electrons, but it has an expanded octet, so it can take those 10 valence electrons. It is not that big of a deal for it to have it. It does sit in period 3 or lower. And now when I say period 3 or lower, I mean period 3 down. And as you go down, the numbers go up. So you have period 3, period 4, period 5. But anything below on the chart, period 3, can have an expanded octet. So I want to make sure that you guys understand where that expanded octet is coming from. So now we have another rule. Exception number 6. This should be close to the last one if we're not at the last one. We have odd electron compounds. Odd electron compounds. So let's just show you. Let's just do a nitrogen monoxide. If we do nitrogen monoxide, it needs 11 valence electrons. If I go ahead and just draw my structure, get everything put out there, all my electrons, this is kind of where I'm at. And I'm like, okay, so I have my structure. This is my Lewis structure, right? 2D structure. That's what we're using to determine our octet rules or our resonance structures to see what's more plausible, right? If you're struggling with resonance structures, make sure you check out the resonance structure video in your video library. So what I'm looking at is this oxygen is happy. It has 8 electrons. Okay, and that's great. If we have the 8 valence electrons, oxygen can be happy all at once. Now, so we're in nitrogen, and when we're looking at nitrogen, it only has 5 valence electrons. That's not really going to work out for nitrogen. So what we're going to do is we're going to take 2 electrons away, and we're going to turn it into a double bond. And once we do that, we're going to turn it into a double bond. Now, oxygen now has 8, just like it did, okay? And because it has what it did, now we can circle the nitrogen. Nitrogen has 7, and 7 is completely acceptable because it has that odd electron. It's an odd electron compound. When it comes to nitrogen, nitrogen's a big one. It's the one that's always going to kind of be like this. If it is, you know, it's going to have pretty much 7 and almost all of the problems that you're going to see in the lab. But what we're looking at is nitrogen. Nitrogen now has 7 valence electrons, totally acceptable, and that'll be our final answer. So if you have questions regarding the octet rule or the exceptions of the octet rule, make sure you're reaching out to your instructor. You can check out the video library. It's got other videos, and I hope this video has been informative for you.